Let's continue our motion from where we ended last time. We are still under kinematics, that is the study of motion without involving the force causing the motion. And the last time we ended up under velocity, and today we are going to talk about acceleration and then equations of motion. Equations of linear motion. Let's talk about acceleration. Acceleration, which we use small letter a to represent acceleration. And acceleration is the rate of change of velocity moved with time. The rate of change of velocity moved with time. So acceleration is equal to change in velocity over time taken. And under acceleration, you also have uniform acceleration. Uniform acceleration. Uniform acceleration. That is when the rate of change of velocity moved with time is constant. So we can also call it constant acceleration. And if you draw a graph for constant acceleration or uniform acceleration, you also get a straight line when you plot a graph of velocity in meters per second against time, t in seconds. And you have this one as uniform acceleration. That is the slope will be equal to change in velocity over change in time. And as we know, velocity over time is acceleration. That is uniform. You have a straight line. And you also have non-uniform acceleration. That is when the acceleration keeps on changing. That is when the rate of change of velocity moved with time is not constant. Then we are going to have a curve. That is, if you plot velocity in meters per second against time in seconds, we have a curve. And if you want to find the gradient of this curve, you have to draw a tangent. The slope of this tangent, slope, will be equal to change in velocity over change in time. Change in velocity over. So the slope, which is equal to change in velocity over change in time. Then non-uniform acceleration. And this graph is also called velocity time graph. Velocity time graph. Velocity time graph. And we saw displacement time graph last time we met. So that is for acceleration. And you should also notice that acceleration is a vector quantity. That the direction is involved. And the SI unit of acceleration is also meters per second square, written this way, or meters per second square. You saw this when you started your physics earlier and derived units. Now, let's begin to talk about equations of linear motion. Equations of linear motion. Equations of linear motion. Equations of linear motion. From the definition of acceleration, we know that acceleration A is equal to change in velocity over change in time. And change in velocity simply means final velocity, which we shall use V to represent final velocity minus U which is initial velocity, over time t. So from this equation, you are going to make v the subject. Now we shall have at is equal to v minus u. And then you can say v will be equal to u plus at. And then we call this first equation of linear motion. First equation of linear motion. That is from the definition of acceleration. A is equal to v minus u over t, where the v is final velocity, u is initial velocity over time. And the initial velocity and the velocity of an object, where it begins. If the object begins from rest, we say the initial velocity is 0. And then where it ends becomes the final velocity. So from here, we have plus, or there is minus, we have plus. So v is equal to u plus at. Now let's talk about what we call average velocity. That is average velocity, which is also equal to displacement.